Hi, I'm Pia, and I'm an engineer on the MongoDB Atlas team.
Hi, I'm David, a consulting engineer on the MongoDB Professional Services team.
And today we're going to be presenting Extreme MongoDB Atlas in practice, in which we'll walk through examples of how companies actually use Atlas with extreme workloads and use cases. You might be wondering, how extreme is extreme? Is it as extreme as these off-road riders? How about the 1980s American rock band, Extreme? No, it's even more extreme than either of those. We're talking as extreme as Greek gods and goddesses. Think immortality, great feats of strength, mythical beasts. So now we're all on the same page. Let's get into the presentation. If you're not familiar with MongoDB Atlas, we are MongoDB's database as a service offering. You might have heard of the Titan Atlas who held up the entire world. MongoDB Atlas is kind of like that, except that we hold up your entire workload. So let's go over what we'll be covering today. We're going to discuss several real-world usages of Atlas in which customers with extreme requirements were able to use the platform to achieve their goals. The first case we'll be covering is around how a customer with a very large amount of data was able to migrate to Atlas smoothly using our live migration tool. Once we've talked about migrating to Atlas, we'll go deeper on some of the powerful services we offer as a data platform. We're not just a database and have a broad suite of services to leverage and analyze your data with. Next, we'll talk about how our API allows users to think outside the box with Atlas, integrating it into their own applications and existing workflows. Finally, we'll discuss a customer that was able to use Atlas to scale up and down dramatically to fit the varying nature of their application workload. Atlas makes it very easy to scale up and out so you can focus on growing your business and not have to worry about the logistics of scaling your database. Okay, so let's get into the first case. If you're not familiar, in Greek mythology, the river Styx forms a boundary between the underworld and the world of the living. It is said to be impossible to cross unless you pay a fee to Charon, a ferryman who's able to carry souls across in his boat. Migrating an in-use database can sometimes feel similar to crossing the river Styx, but let's talk about how Atlas's fully automated live migration service can help you navigate the murky waters. Passing it over to David to talk us through how a multinational IoT company was able to move an enormous amount of data into Atlas using live migration.
In professional services, we get to work with customers that push our platforms to their extremes quite often, and we see how people use features like live migration in the real world. At the end of 2019, I worked closely with one such customer that wanted to utilize live migration for their cluster. This customer is a large multinational that creates wearable IoT devices. They have been using Mongo as their primary database since MongoDB 2.4. Recently, they decided to migrate their cluster to MongoDB Atlas and upgrade to version 4.2. The source cluster was still running on mmap v1. The cluster the client wanted to migrate was a 9 terabyte 3-shard cluster. The migration had to be done with as little as possible downtime. So we worked very closely with this client to develop a migration plan. The plan included 3 phases. The first phase had professional services working with the operations team to simulate a cloud-based cluster that was closely emulate the customer's cluster. This cluster was then used to test the upgrade from 2.4 all the way to 3.6, following each of the required steps to eliminate as much risk as possible. Phase 2 would involve upgrading and migrating the client's staging cluster to Atlas as a dry run. The final phase would involve the upgrade and migration of the live production systems with as little as possible downtime. During the first phase, we built the cluster and documented each step needed to upgrade while implementing our best practices. This resulted in a runbook that fully documented the upgrade process with repeatable steps. Once we completed all the commands in this book, we would have a cluster running on MongoDB 3.6 with as little as possible downtime and ready for migration. During phase 2, we worked remotely with this customer's operations team, which allowed us to run through the upgrade and partial migration of the staging cluster. During this phase, we discovered a few interesting issues. The client was utilizing Azure and wanted to peer the VPCs. At the time, MongoDB Atlas required Azure and GCP customers to either use internal or external IPs. Setting up peering required internal IPs. The problem was that live migration required external IPs. We decided to prioritize the migration. Once the migration was completed, we would request that MongoDB support switch the cluster back to private IPs, as it required a script to be run to fix some DNS entries. Phase 3 was completed on-site with the customer. We again did the upgrade, and with a few stumbling blocks here and there, we then performed some network gymnastics to ensure the client had the CIDR blocks they wanted after we completed the migration and re-enabled peering. We turned the private IPs on, we peered the VPCs, we built a temporary cluster, then terminated that cluster, switched the public IPs back on, and built the destination cluster. The VPC was created during the temporary cluster deployment. That VPC persisted through to the destination cluster, which meant when we re-peered after we migrated, we had the same CIDR blocks. A few things you might want to consider when migrating a cluster to MongoDB Atlas using Live Migrate. The first thing is the cluster configuration has to be the same layout as from the source as well as the destination. For us, that meant we needed 3 shards in the destination. Depending on the version you are migrating from, turning off enforced key limits can save you from index builds failing. Migrating 9 terabytes of data, you are going to sit there waiting for a while, so you don't want anything to go wrong. Increasing the oplog size is also very important. The migrating tool uses the oplog to keep up with writes, and if it can't catch up within the oplog window, then the migration will fail. So in our case, we had to increase the oplog size from the default 50 gig to 500 gig. So when you're planning a migration to MongoDB Atlas, get in contact with professional services, or at the very least with MongoDB support, and we can advise you at the best oplog size for your migration. So we pointed our live migration at the source cluster and started the migration. This process took around 4 days for us to complete, moving the 9 terabytes from the source cluster running on MongoDB 3.6 on MAP v1 into its new home in Atlas. Once the counters caught up with the writes, we could prepare for the cutover. We stopped all the application servers, and when the counters reached 0, we did the cutover. Once Atlas completed the configurations, we rerouted the application servers to the new cluster and started the applications back up. This ended the migration process. Once we completed that, we did a review of the cluster, and we found that the 9 terabytes cluster that we started with had reduced in size to 4.5 terabytes due to the use of the new WireTiger storage engine in Atlas. We discussed the advantages of limiting a shard to about 1 terabyte, and the client decided to move to 5 shards. Being an Atlas, we added 2 initial shards, and after 2 days of balancing, the cluster was nice and evened out, and the overall performance of the cluster had improved. Pia has some more insights on how live migration worked and how Atlas addressed one of the issues we encountered.
Okay, so now let's talk a little more about how live migration works under the hood. David mentioned that during the live migration process, there's a period of time where the initial migration is occurring, which is marked by the green bar at the bottom of the cluster. After that, Atlas walks you through the process of pointing your application to the new cluster. During this time, Atlas is running the Mongo Mirror tool under the hood, which first performs an initial sync which is tracked by the green progress bar. Then it continuously tails the op log of the source cluster, replaying those changes onto the target Atlas cluster. Atlas sets a 72-hour window in which cutover is allowed, which can be extended by 24 hours at a time. As we saw during the customer example, in order to perform live migration, Atlas accesses your source cluster using a hostname and credentials that you provide during the setup phase. You are also required to whitelist the live migration servers so that they can connect to your cluster. This is all we need from you in order to take care of the migration process. To connect to the target cluster, Atlas creates a temporary whitelist entry and user, which are removed at the end of the process. For sharded clusters, we stop the balancer, break the target cluster into replica sets, and conduct the same process. Okay, so now I'm going to go a little deeper into one of the limitations David mentioned earlier. This customer was not able to use Azure peering during live migration. This was because, unlike AWS peering, GCP and Azure peering connections did not support split horizon DNS when we were integrating them with Atlas. This means that the same hostname could not be accessed over both the public and private internet. To solve this when integrating Azure and GCP peering with Atlas, we created a connect via peering only mode. When enabled for a project, all clusters could only be accessed over the private internet. Since the live migration servers connect to the clusters over the public internet, Azure and GCP peering was not compatible with live migration. Now, split horizon capabilities are built into the MongoDB server itself for MongoDB versions 3.6 and up. This feature allows each node to have multiple host names. As a result, we can use separate host names for private and public connections to the cluster. This allows live migration in Azure or GCP peering to be used at the same time. Atlas's live migration is a fully automated service that just requires a few pieces of connection information from you and will take care of the rest of the process. There is limited downtime during this process. The only downtime your application will experience is during the cutover period, in which you switch over rights to the new hostname. Lastly, live migration supports a wide variety of use cases, helping you migrate no matter where you're coming from or how much data you have. For example, even if you're currently hosted in one cloud provider, you can migrate into Atlas to any other cloud provider of your choice. Okay, so now that we've talked about migrating your data into Atlas, let's delve into how Atlas works as a data platform. Cerberus, the underworld's guard dog, was said to have many heads with which to fend off attackers. Similarly, the Atlas data platform has a broad suite of services on top of the database, which you can use to analyze and understand your data. David will now discuss how a shipping and logistics customer was able to leverage the Atlas platform to build out a production-grade event processing system.
Our second customer is a large distribution organization that contacted professional services to help them liberate their data from their large tabular databases. They recognized that their current systems were less flexible and did not perform as required. During the discovery phase, we identified that the client wanted to build an event processing system that would allow them to keep track of package updates and events. They wanted to keep a single source of truth that is current and can easily be extended when needed. One small challenge was that they were handling around 70 million events per day, of which 80% is processed during office hours. Now that's around 2,000 events per second. We considered writing an application based on change screens that would watch a staging collection and would update the packages as events arrive. The client expressed a preference to use serverless technologies that would take the management burden of this system away from them. We explored the use of MongoDB Realm and the ability to use filtered database triggers in Atlas. We started to experiment and built a small working event handler for one of their event types in about an hour. They were intrigued, but they were not keen on writing code in web UI. They wanted to know if they could integrate the project into their source control and continuous integration systems. We developed a small example project for them and used the Realm CLI to export the Realm project and add it to the project to a source control. The function we wrote was pretty simple, but effective. We started off with some error checking. Once we knew we had all the required fields, we pulled in the MongoDB context and opened a cursor to the collection we wanted to write to. We set the ID into a variable for reuse, and we grabbed the contents of the event as our update statement. When setting up a trigger in MongoDB Atlas, you have the option to keep the order of the events. But this can be a bottleneck, especially if you're doing 2,000 requests per second. In our case, we wanted to process the events as fast as possible, even if they arrive out of order. We added upsert to our update function to handle this eventuality. As Realm functions are JavaScript, we can write a small simulated Atlas context to test functions locally. We include a MongoDB in-memory database for full MongoDB functionality. There is no mocking needed for this little module. Combining this with a unit testing framework like Mocha allows us to write testable code that can run as often as needed. Functions can now be unit tested. We can create coverage reports based on these tests and integrate it with standard CI tools. We define a test suite and a single test here. We run the function we want to test twice, once with the name John Doe and the second time with the name John Smith. We can then load the person from the database and check that the required updates were made and assert as needed. All of these tools combined with the Realm CLI for publishing can be added to the continuous integration system. The CI can then run automated tests, coverage reports, deployments based on the standard CI procedures. Here are some more details on how triggers work behind the scenes.
David talked about how this customer was able to make use of Atlas triggers to build a responsive event processing platform. I wanted to briefly highlight the fact that Atlas triggers is built on top of MongoDB change streams, which is a feature in the MongoDB core database. Atlas triggers is a really cool example of how we have been able to build upon our own features to meet the evolving requirements our customers have in a cloud environment. This customer story is a testament to how robust and flexible both the underlying feature and the Realm integration are. In this example, we've seen how a large-scale customer was able to leverage the cloud platform to solve complex problems that their previous infrastructure did not support. As you can see, the MongoDB Cloud Platform is an incredibly robust and powerful tool. Each product on our platform is built by the same team that builds the core database and is specifically tailored to work with MongoDB. Everything you need to run, analyze, and enhance your application can be found in one central place with a unified billing system. Lastly, we are a cloud-agnostic platform, making it really easy for you to switch among the various cloud providers with the click of a button. We're constantly working to build out our platform, and here are some of the features we've recently released. We've integrated Realm Sync with the MongoDB Stitch platform to enable users to easily sync data between Atlas and mobile devices using the Realm open source database. This empowers mobile developers to quickly build highly performant cross-platform apps that sync in real time and work even when offline. We've also added support for GraphQL so that you can automatically generate GraphQL APIs off of data stored in MongoDB's cloud, and the API will adapt as your data changes. Another feature we just released, which I was one of the project leads for, is Online Archive. This feature is built on top of Atlas Data Lake and seamlessly archives user data from Atlas clusters to S3 buckets. This feature allows you to specify a time period after which you want data from a particular collection to be offloaded to S3, and Atlas will take care of that for you. This greatly decreases the cost of storing this data, but still allows you to manage all of your data from one central place. So now let's switch over to talking about the Atlas API. Atlas has a robust API that allows you to mold your Atlas deployment the way Hephaestus, god of the forge, molds iron. Passing it over to David to present how a manufacturing company used the Atlas API to solve a very interesting problem.
About 1.5 years ago, we worked with a client that specializes in manufacturing. The client saw significant growth in demand for MongoDB clusters within their company. The manual process of getting systems deployed and configured was slowing down development teams. Our first suggestion was use MongoDB Atlas, to which the client replied, "We want that too, but we also require automation inside of our data centers." The idea here was that the developer can order a MongoDB cluster that runs on a variety of hardware and software through a standardized UI. They wanted to expose an order form using an internal website with some sizing and destination architecture, allowing their users to deploy a cluster on VMware, Kubernetes containers, or even Atlas, depending on their project's needs. Ops Manager exposes a public API. And combining this with some orchestration and automation tools, we were able to deploy to VMware quite quickly. The Kubernetes operator allowed us to then deploy to containers, as it also uses the Ops Manager public API. MongoDB Atlas also exposed their public API, which we used to automate this process for Atlas. The process of initiating a cluster using command line tools can integrate very easily with most automation and orchestration tools. Deployment of a replica set can be done in as simple as 3 small steps. First, we create a standardized deployment template. We can then, with all the default values in it, we store that as a cluster template.json. We can then use a small tool called JQ. This allows us to manipulate JSON in the command line. We update the values we want to change using JQ. Here we are setting the cluster name, the size, the region, and the version. And we save the resulting object as basic-cluster.json. We can then send a post request to the cluster's endpoint with the JSON document as the data. In Atlas, we will get a newly provisioned cluster. The Atlas and Ops Manager APIs are very similar. So the commands we used for Ops Manager was very similar to these we just looked at. These commands can easily be integrated with customers' tools and seamlessly automate the provisioning process of clusters in VMware, containers, and MongoDB Atlas. Pia is going to have a look at other ways that you can interact with the API.
So David just discussed how a customer was able to use the Atlas API to manage provisioning clusters. The Atlas API also provides endpoints to manage many of our other features, including user management, network access, and additional features like Atlas Data Lake. As we saw through the customer example, the API is extremely flexible and integrates well with existing code and systems. In terms of security, we use public-private API keys to secure access to the endpoints. Roles can be assigned to these keys in order to limit access to more sensitive endpoints, such as cluster creation and deletion. Another added benefit of using the API is that it allows you to limit how many users in your organization actually have access to the Atlas UI. There are many ways you can interact with the Atlas API, such as through our Atlas Terraform provider. MongoDB also has drivers for a variety of languages, and the Atlas API can be used alongside those drivers in the language of your choice. Lastly, we have extensive documentation for every API endpoint available, which can be found in a link at the end of the slide deck. So far, we've discussed migrating to Atlas, using Atlas as a data platform, and building applications around Atlas using the API. Now let's talk about how Atlas scales up and out to support your changing workloads as your business grows. This seamless and painless scalability empowers your application to be like Thor, the almighty god of thunder. David is going to go over how Atlas was able to support a gaming company's needs through an intense fluctuation in usage.
I worked in the games industry before joining MongoDB. Recently, I was drafted in to help out a large gaming client with an upcoming project. Game clusters normally have one major requirement, and that is high availability, as any downtime can mean players just stop playing your game. With this in mind, the customer was targeting MongoDB Atlas, as they had a proven track record for high availability with this customer. The games industry has some fascinating load patterns. Mobile games start slow with only a few users. If they get featured, they could have substantial peaks, after which they have long tails. AAA games and console games tend to have fixed release dates, which generally revolves around significant events like Christmas. For this reason, game companies require handling immense traffic at specific times, and each time an add-on is added, the load resurges. The cluster that they were trying to spin up was 30 shards. 30 shards with 6 members in each replica set. That is 183 hosts, which has to be provisioned at a click of a button. Coordinating 183 servers with automation is not such a massive task if you have the hardware and you know the capacity is available. Being in the cloud, this becomes a little bit more tricky. We work closely with the cloud provider and the client to allow us to provision these servers as quickly as possible. These servers would be distributed across 3 regions to allow them low latency reads, low latency writes, and regional outage protection. Once we had the hardware and the cluster was running, the client wanted to understand how long maintenance tasks would take. First, restoring a backup. The process did take some time, but still within the required recovery time objective. The client wanted to see how long it would take to scale the machines from M50 to M30. The task did complete with no downtime. The customer was satisfied that even if it did take a long time to do, it was possible. The final test scaled the cluster from 30 shards to 6, with only 2 shards in each region. Again, this is not an insignificant task to do, but succeeded in the expected time threshold for the customer. At this point, the client was happy that they were ready for the upcoming launch. MongoDB replica sets and the multi-region deployment would provide them the required service uptime. MongoDB Atlas would allow them to scale to their needs, be that up, down, in, or out. Pia has some more information on some exciting new features to help manage workloads like this.
As this customer story exemplifies, Atlas is well equipped to support you through whatever usage cycle your application experiences. You can choose to vertically and horizontally scale your deployment with the click of a button, and we will handle all of the nitty-gritty details regarding hardware management and MongoDB cluster communication. We also enable you to manage deployments in the 3 major cloud providers in one central location and provide seamless migration among the 3. With 70 supported regions on Atlas, as well as support for cross-region and globally sharded clusters, you can ensure low latency all over the globe, as well as high availability. Enabling our customers to scale their deployments seamlessly is something we think about a lot on the Atlas team. Let's talk about some new and upcoming features that we've been working on. Dedicated Atlas clusters can be configured to automatically scale their cluster tier, storage capacity, or both. Atlas will then take care of scaling your deployment up and down in response to sustained changes in usage, and you don't have to give it a second thought. We're also planning for the capability to deploy clusters across cloud providers. This would defend clusters against provider-level outages. For example, you could deploy multiple nodes in the same region across multiple providers, and if one provider goes down, your cluster will still be available in that region. This feature will make a great addition to our strong suite of services to help you achieve the highest availability possible. We've covered a lot of ground today, so let's take a second to discuss some takeaways. So we've had a chance to get a first-hand look at some incredibly complex Atlas customer cases that span a wide range of industries. Each case had some pretty intense requirements, whether in the form of data size, throughput, customization, or fluctuations in workload. Despite the extreme nature of these cases, Atlas was able to meet their needs pretty much out of the box. This was just a small subset of the vast array of exciting and innovative ideas that our platform helps to make a reality. We work hard on our ever-growing set of features to make Atlas a powerful tool that can help you realize your business's full potential. Furthermore, David and the rest of the professional services team have a huge repertoire of Atlas experience that they can draw upon to help you navigate complicated requirements. With what Atlas provides out of the box and the vast knowledge of our professional services team, we can help you achieve whatever you set your mind to. That's all we have for you today. Thanks for joining this session.